Hi class, this is Course 2, Lesson 59, Adding Integers on the Number Line. So, in order to know what we're going to talk about today, we need to recall that integers are the whole numbers and the opposites of the positive integers. Okay, so what we're talking about, remember whole numbers are the numbers 0, 1, 2, 3, and so on. And integers include all of those whole numbers plus the opposites or the negatives of all of the numbers except for 0. Okay, so we're talking about -3, on back to negative infinity, -2, -1, 0, 1, 2, 3, and so on. Okay, so some new information. Signed numbers, so you're going to see in the textbook or problems will be referred to as using signed numbers. Those are all the numbers that we just talked about except for 0. We call them positives and negatives. Okay, that's what they are. They both have signs. One is positive and one is negative. That's all it means by signed numbers. Signed numbers have a sign, we just talked about that, positive or negative, but they also have a value, and that value is the absolute value. So we're going to talk about absolute value today also. Copy this chart down into your notes. You can have a numeral, then we have the number that's assigned to that, the sign, and the absolute value. So here I have +3 and -3. Those are the numerals. And if you were to say those, you wouldn't say plus or minus. You would say that the number shown up here is +3 and the number shown here is -3. And so that makes the sign of this first one, that's the plus sign, the positive, and the sign on the bottom is the negative sign. And the absolute value, and we're going to talk about this in a little more depth here in just a second, is 3 and 3. Okay, so you can see that we basically break these numbers apart. It has a sign and a value, a sign and a value. Okay, so absolute value, we've just touched on it briefly. That is how far, or the distance, a number is away from 0. Okay, and so here's an example. The absolute value of 3, that's what these bars mean. That's the symbol for absolute value. Okay, so you're gonna, if you see the two vertical bars like that, it means how far away is whatever's inside from 0. Okay, so it's a distance. So if we looked at a number line and we had 0 here, we would have 1, 2, 3. This distance is 3 units. That's how we get the 3. On the other side of 0, we have another number that is 3 units away. It is -3. That's still 3 units from 0. So the absolute value of -3, how far away is whatever's inside those symbols from 0? It is 3 as well. So when you're talking absolute value, you're going to have two numbers that can go inside the absolute value that are the same distance from 0, because you have one set of values on the right and one set of values on the left from 0. So let's simplify. So I'm going to go through all 5 of these problems. If you want to try them, pause the video and then play when you're ready. Okay, so the absolute value of -2/3 is just asking you how far away from 0 is -2/3. So if I put 0 here, and I put -1/3, -2/3, it's what is the distance between 0 and -2/3. Well, it's 2/3 away from 0 in the negative direction. What about 100, the absolute value of 100? Well, there again, if I put a 0 here and I put a 100 here, how far away from 0 is the number 100? It is 100 units away from 0. How about the absolute value of 0? How far away from 0 is the absolute value of 0? Or how far away from 0 is 0? Well, it's nowhere. It's right there. So absolute value of 0 is 0. And this is the only time that you will have one answer. These two problems on the bottom are a little trickier in that you have to simplify in here before you do the absolute value. Okay? So we need to subtract from 2, 3. So if you had 2 and you subtract 3, you would end up with -1. And now we're saying, what is the absolute value of -1? Well, how far away from 0 is -1? It's 1 unit away. On this problem, we need to do the subtraction first. Those absolute value symbols, they're grouping symbols, like a parenthesis or a fraction bar. We need to do whatever's inside first. So if we subtract 2 from 3, we get 1, and how far away from 0 is 1? It's 1 unit away. So if you're inside absolute value, if you reverse the digits in a subtraction problem, your outcome will be the same after you calculate the absolute value. So again, absolute value is a distance from 0. Absolute value is not going to be negative. Now, if you think about that for a minute, you'll know why. Absolute value is a distance. Distances are not negative. Distances are positive in a direction. Okay, and that's what we have here. This is 2/3 to the left, 100 to the right. That is what we're doing here with absolute value. Now, positive and negative numbers, we talked about how they're signed numbers. They can also be called directed numbers. They have a sign, and that shows the direction. So, negative numbers go to the left, and positive numbers go to the right. And we can use that information to help us add on a number line. So if we're going to add, we're going to take -2 and we're going to add a +7 to it. And here's what you're going to do. You are always going to start these. You're going to get problems like this that say, show this on a number line. And this is exactly what I expect that you will do. You will draw a number line, probably not out to 15 and -15. That'll end up being up to the individual problem. But you will always begin at 0. So we're going to start right here at 0. And you draw an arrow that go the number of units in the direction of that first term. Okay, so we need -2. So we're going to go a distance of 2 in the negative direction. So we're going to start here and we're going to draw an arrow that goes this way 2 units, and we're going to show this. There we go, -2. It's -2. That's where we went. Okay, then we're going to draw the next arrow with the units in the direction that it tells us to go into. So we're adding +7. So we need to draw a length of 7 in the positive direction. So we're just going to go up from here, and then we're going to go over 7. Now, this does not mean you go to 7. This arrow needs to be 7 units long. So we already did 2, 1, 2, 3, 4, 5, 6, 7. So this is a plus 7. This length of this arrow from here to here needs to be 7 units long. So it needs to be the same length as this to this up here. It's 7 units long in the positive direction. This one was 2 units long in a negative direction. That way we can show our answer as 5, positive 5. So if we take negative 2 and we add a positive 7 to it, we end up on the number line at the number 5. Okay, so you will be asked to do this on your assignment. And here's a handy fact. The sum of two opposites is always 0. So let's show this on a number line. I'll put a 0 in here. 1, 2, 3. Negative 1, negative 2, negative 3. Okay, I'm going to switch to the red pen so that I can do this. I'm going to begin at 0. So I'm going to start here. I'm going to go to the positive 3. So I'm going to start here at 0 and go in a positive direction, so go to the right a length of 3. That was 3 units, so that was plus 3. And then I'm going to add a negative 3. So from where my arrow was, I need to go in a negative direction, so to the left 3 units. And that's the minus 3, which ends up back at 0. So that's how you can show that two opposites, when you add them, their sum will always be 0. Okay, so a lot of different terminology for positive and negative numbers, signed numbers, directed numbers. We talked about absolute value and how to add numbers on a number line. So you'll get a lot of practice in the practice set with your problems. And with that, I guess I will see you in class.